And there we go. Okay, so guys, these are the three things that we're going to do today. We are going to do ions. Once you understand ions, we're going to check it off our mental list. Then we're going to do isotopes. When you get that, we'll check it off our mental list. Then when we're done with average atomic mass, we're done for the day except for one little extra thing. Can't believe I'm doing this. Extra credit. You guys know about me and extra credit, right? In my little world, it's sort of an insult to everybody's intelligence because normally it turns into baking cookies or cleaning desks, which has absolutely nothing to do with learning or teaching or school. Guys, we are going to give you the opportunity today to do some extra credit. Understand that you never get to come to me and go, hey, can I do extra credit? It will always be initiated by me. This will be the only opportunity this quarter. So guys, there will be the opportunity for some extra credit today. I'll sort of introduce you to it when we talk about average atomic masses. It will be due the day of the test. We'll talk more when the time comes. All right, so ions check, isotopes check, average atomic mass done for the day. Yo? All right, so guys, let's tie all this back to our homework. Ready? Ions, isotopes, and average atomic mass are actually all represented in your homework. So check this out. Don't write this down because it's just going to muck up your homework. But guys, here's the idea. When we were grading homework, we said that the protons column and the electrons column are the same as the atomic number. So guys, why is the atomic number the same as the number of protons? Well, that's what it tells you is the number of protons. Now guys, why are protons the same as electrons? Do you remember? This is going to be on the test. You'd better know this. Why are protons and electrons the same? What does that do to the atom? Neutralizes it. No charge, right? We have this guiding principle that says atoms don't have a charge. But guess what? They can if they change. So guys, what we're going to do today is we are going to talk about what if protons and electrons are not the same? Well guys, then they are no longer called atoms, they are called ions. And that's our first concept, right? Ions, isotopes, yeah. So if these aren't the same, so if the protons and protons and electrons aren't the same, they're called ions. That's goal number one. Now guys, thought number two, topic number two, average atomic masses. Guys, why should these be whole numbers? Think through this with me. Why should the atomic mass be a whole number? Well, what does the atomic mass tell us? The number of what? Protons and, come on gang, protons and neutrons. What's the mass of a proton? 1. What's the mass of a neutron? 1. When you add up a bunch of ones, it should be a whole number. But guys, these ain't whole numbers. Why? That's our second thought for the day. Why are the numbers on the periodic table not whole numbers? Then question number three, guys, thought number three is how do we calculate average atomic masses, these numbers on the periodic table, and then for extra credit, where on earth does this data come from that allows us to come up with these masses? You get the idea? So number one, what if these ain't the same? Number two, why ain't these whole numbers? Number three, how do we come up with the masses on the periodic table? Done for the day. Good? Thought number one, ions. Write it down. So guys, what is an ion? Well, an ion is an atom that has a charge. So by definition, ions are atoms with a charge. Guys, I'm realizing I forgot to open my drawing tools. Just a second. There we go. All right. So guys, here's the $11 question. How on earth could you give an atom a charge? You can write this down with me if you want, off to the side. The idea is this. Uh-oh. Oh, good. Okay. So guys, take, for example, a carbon atom. Carbon is element number 6, and it has a mass of 12. So what does that tell us? Well, 6 protons and 6 neutrons in the nucleus, and then 6 electrons zipping around in space, right? Okay, now, if we wanted to give this carbon atom a charge, what could we do? Well, what about this? If we change the number of neutrons, would that give the atom a charge? No, because neutrons ain't got a charge. So now, What could we change to give this atom a charge? Number of protons, maybe? So guys, what if we did this? What if we took away a proton and made this 5 protons? Does this atom now have a charge? Yeah, because we've got 1 extra electron than proton, so this now has a negative charge. But we've got a problem. What's the problem? This ain't carbon anymore. So that doesn't work. Guys, we can't be messing with the protons because that changes the identity of the element. So if we can't mess with protons and neutrons don't do any good, what's left? Electrons. So guys, when we form ions, we do it by changing the number of electrons. And guys, this can happen in one of 2 ways. The first way is what is called an anion. This does not rhyme with onion. It is 2 distinct syllables. It's an ion. So guys, an anion is an atom that is negatively charged. So ready? Neutrons doesn't do anything, can't mess with the protons. So guys, how do we give an atom a negative charge if all we've got left is electrons? Do we add them or remove them? Add them. So guys, an anion is formed by adding or gaining electrons. So when we talk about anions, we say that these little guys are electron rich. They have lots of electrons. So what's our other option? Well, if we've got negative ones, obviously we have positive ones. And guys, positive ions are not called cations. They are called cations. Again, 2 syllables. Cations are positively charged. So guys, how do we make them? How do we give an atom a positive charge? Take away electrons, right? If you take away negatives, the thing that's left will be positive. So these are formed by losing electrons, and they are electron deficient. So guys, how on earth are you going to remember that cations are positive and anions are negative? Ready for my stupid little trick? What I do is this. The T in cation looks like a plus sign. That's the best I got, but it works. All right, so you guys good on the concept? Anions, negative, add electrons. Cations, positive, take away electrons. Yep. All right. So guys, now what you've got to do is figure out how ions are different than atoms. So do this with me. Down there in the bottom left-hand corner, we're going to play with a couple of these to make sure you understand what you're doing. Once we establish that you guys are all comfortable with this, then we go on to isotopes, then average atomic mass, and then we're good. So guys, calcium with a +2 charge. Kind of like we did last time where we're drawing circles. Remember, the middle is the nucleus. The outer circle is where the electrons are, drawn to scale. The big circle would be the size of a Lavelle Edwards Stadium, and the inner circle would be the size of a marble. A little hard to draw to scale, so we're just going to draw it like this. So guys, find calcium. It's over here on the left. It is element 20, and it has a mass of 40. So guys, if calcium has an atomic number of 20, you already know this because you did well on the homework. How many protons? You got it. Now, how many neutrons? Mass is 40. 20. 20 minus 20 is 20. Now, guys, we need to talk about electrons. So do this with me. How many electrons should calcium have? 20. Now, what if it has a +2 charge? What can we do to the electrons to give this a +2 charge? Take 2 away, and so this becomes 18 electrons. Now guys, you see the mistake that you're going to make, right? You're going to see this plus sign and you're going to think, oh, that means add electrons. It's the opposite. Because electrons are negative, to give it a positive charge, you take them away, so that would be 18. Yo? All right. So guys, if you're good on that one, let's try one more. If you can do this all by yourself, I would say you're good to go. We'll answer questions, and then we'll go on to the next idea. So guys, nitrogen with a -3 charge. Nitrogen is element number 7. It's in red if you've got one of our periodic tables. It's on the right. It's got a mass of 14. By the way, guys, I don't think we talked about this. Well, I know we didn't. I'll never ask you to memorize the periodic table. Some chemistry teachers still find that useful. That's up to them. I won't have you memorize the periodic table, although most of you will memorize it by accident because you're going to fiddle with it so much. But guys, we're not going to do that. Unless you want to. No? Okay. All right. So have I given you enough time to fiddle with this? All right, so here we go. So nitrogen is element number 7. 7 protons. Its mass is 14. 14 minus 7 is also 7. And it should have 7 electrons. How do we give it a -3 charge? Add 3, adds up to 10. There you have it. Questions about ions, their names, how they're formed, or their particular structures. Can we check it off the list? Yeah.
Where are these found?
Everywhere. Yeah. As often as you see atoms in their neutral states, you see atoms as ions. I mean, they're so a great example is our blood. You've heard of hemoglobin, and this is so cool. So hemoglobin is the stuff that makes your blood red, and hemoglobin is this enormous protein. I mean, it's really on a molecular level, it's enormous. And right in the middle of every hemoglobin molecule is an atom of iron. And this atom of iron has a +2 charge, which is exactly the charge that it needs to attract an oxygen atom, lock onto it, and carry it like a dump truck through your body to deliver that oxygen to your cells. So and that's actually, it's the iron that makes our blood red. So right in the middle of every hemoglobin molecule is an iron ion that allows it to attract oxygen and carry it around. It's all, you'll see. We'll deal with atoms that are ions almost more than we will with atoms in their neutral states. Yeah, they're everywhere. It's really cool. All right, you guys good on ions? Mental check? Yep. All right, isotopes. Thought number 2. Oh my goodness. Let's see. Click. Oh, this is, all right, I'm getting close. Here we go. So guys, the next thing we need to do is talk about isotopes. So gang, given the introduction that we went over as we were looking at your homework, what is the next question that we're answering? What does isotopes help us understand? Do you remember? Why the masses are not whole numbers. Now guys, are you all comfortable with the idea why they should be whole numbers? If it's protons and protons weigh 1 and neutrons weigh 1, they should be whole numbers. So guys, why is it that these are not whole numbers? And guys, the answer is because atoms don't always have the same mass. So let's talk about this. Let me define it for you first. Isotopes, guys, are atoms of the same element that have different masses. So guys, once you get that down, don't write down anything else that comes up on this screen. Just trust me. Excuse me. Y'all good? Okay, so guys, here's the idea. Let's take, for example, the element carbon. Carbon, again, is element number 6. And guys, first thing we need is a sample of carbon. So where do we go to get carbon? Inside your pencil. You guys all know that this is not lead. This is really disappointing. Even though when you go to Walmart and you buy this, it actually says on here, pencil leads. This ain't lead. That's illegal. Guys, lead is actually toxic. It causes birth defects. It causes brain damage. They can't sell lead in pencils anymore unless you go to art shops and you get special pencils. But guys, out there, this is not lead. What is it? Do you know? It's graphite. And guys, graphite is actually pure carbon. So inside this pencil carbon, it's not lead. Inside this graphite, which is just carbon, guys, all of this is carbon. So let's see if you can do this in your head. What do all the atoms inside of here have in common? They're all carbon. What makes them carbon? 6 protons, right? If it wasn't 6 protons, it wouldn't be carbon. So all of these have 6 protons. But guys, here's the thing that you need to know about these atoms. They don't all weigh the same. So let's talk about it. So there's actually 3 different types of carbon. We've got carbon, carbon, and carbon. They all have 6 protons. They also all have 6 electrons. Guys, how are they different? Well, guys, there's one isotope of carbon that has 4 neutrons. There's another isotope of carbon that has 6 neutrons, and there's another isotope of carbon that has 8 neutrons. So how are they different? Well, guys, this weighs 10, this weighs 12, and this weighs 14. Now, can you figure it out? Where did the number on the periodic table come from, 12.0107? It's an average. But wait a minute. Hold on. What is the average of 10 and 12 and 14? 12. So how can the average be 12.0107 if the 3 types that exist weigh 10, 12, and 14, and the average of that is exactly 12? Not more precise. It's not exactly thirds. Guys, when we find carbon, like in our pencils, it is not 1/3 this, 1/3 this, and 1/3 this. Therefore, the average is actually sort of skewed, kind of like when you calculate your GPA. Have you ever thought about how to do that? The number of A's times 4, B's times 3, C's times 2, and so on, add them up, divide by the number of classes you're taking. Well, guys, similarly here, because it's not a third, a third, a third, the average is not exactly 12. So what about this? Because the average is above 12, what do you know about these relative amounts? There's more 14, right? Do you get the idea? There's more 14 than there is 10. Okay, so guys, do you understand the idea behind isotopes? Isotopes are atoms of an element that have different masses. In, for example, carbon, there are 3 different isotopes of this element. They have different masses because they have different numbers of neutrons. Groovy? Okay, then guys, I got to ask you a question. Which one of these is really carbon? Is it the 10, the 12, or the 14? Which is really carbon? All of them. Guys, they are chemically the same. They react the same. They behave the same. They are all the same element. The thing that makes an element is the number of protons, and they all have 6 protons. They're all carbon. They just have different masses, but they're all isotopes of each other. They're all carbon. You okay? Okay, so guys, let's summarize all of that. You ready? Here it goes into your notes. So here's what we know. Isotopes are atoms, same differing mass. How does that happen? Different numbers of neutrons. But guys, you got to be comfortable with this. There is no correct isotope of an element. It's not like carbon is really 12 and the other ones are mutants. Guys, there is no correct isotope. They are all isotopes of each other. So guys, all atoms of an element are isotopes of each other, and they all behave chemically the same. Did you guys know that about pencils and lead? Yeah? All right. Here I thought I taught you something. Taught you? You should share it around the dinner table tonight as you're gathered with your family. Guess what, family? Do you guys know about the research on that? This is fascinating. You ready? What is the #1 predictor in the United States? What is the #1 predictor in the United States of dropout rate, teen pregnancy rate, and drug addiction? There's one thing that if this is happening in a person's life, you can tell if they're going to get pregnant, you can tell if they're going to be a drug addict, and you can tell if they will drop out of school. One thing. Family dinner. Isn't that weird? It's not money, it's not socioeconomics, it's not family structure, it's do you eat dinner with your family? Isn't that weird? It has the tightest correlation to all of the things that can go wrong in a teenager's life. It's really fascinating. Why were we talking about? I don't know. Anyway, so you guys okay with isotopes? Oh, because Paxton was going to go tell his family about lead. All right, I knew there was a connection. So in addition to not getting pregnant, you'll also be sharing information with your homies. Good heavens. Are you guys okay? Because I got to stop talking or I'm going to get in trouble. You guys all right? Okay, so guys, do this then. Don't try to write this down, but I want to introduce you to another idea of this idea of isotopes, just because we're going to refer to this later. So guys, neon. Here's the hazard. You're now thinking all elements only have 3 isotopes. Guys, some elements have no isotopes. There's only 1. Some elements have 5, 6, 7 different isotopes. I just happen to pick examples of atoms that have 3. So guys, neon. Neon exists as 3 different isotopes. In order to be neon, you've got to have 10 protons. By the way, neon, element number 10, neon signs, right? You pass a current through neon and it glows red. Okay, so anyway, neon exists as 3 different isotopes. One has a mass of 20, that's got 10 neutrons. One has a mass of 21 with 11 neutrons. One has a mass of 22 with 12 neutrons. So guys, again, the idea is they're all neon, they all react the same, they all have 10 protons. The difference is the number of neutrons and therefore their mass. Good? Okay. So guys, with that said then, what are we going to do with this? We're going to do stuff like this. Scratch it again into your notes and let's figure out carbon-14. All right, so guys, let's talk about carbon-14. Here's the way we play the game. This is going to be a little bit new. So you look at carbon on the periodic table, its element number 6, and its mass is 12. Its average mass is 12. So here's what we know. 6 protons or it ain't carbon. Now we've got a problem. The average mass on the periodic table says 12.0107. We round that to 12, but this is telling us 14. Here's the deal, guys. If you are given a mass that is not the average mass, use that one instead. So if there were nothing there, you'd go get the average mass. But because it's giving us a different mass, we just use it. So 14 minus 6 is 8, and then 6 electrons to balance the charges. Now guys, is this possible? Could we go carbon-14 with the +1 charge? Oh yeah, what do? Take away an electron. Yeah. We can have atoms that are both an isotope other than the average and a charged ion. Yeah. That's a good question, and the answer is both. We can do this to atoms, but atoms also do this naturally on their own. Yeah, absolutely. You guys good? Let's do one more. If you're good with this, we are ready for our last idea. So guys, oxygen 17. Notice that it's written a little bit differently. Instead of a superscripted 17, it's now oxygen-17. Again, it's just telling us a mass. You'll notice that the average mass of oxygen, element number 8, is 16. So if the average mass is 16 and they're given us 17, it just means we're going to use 17 instead of 16 because it's not the average mass. So guys, oxygen is element number 8. 8 protons. Then to come up with neutrons, it's 17 minus 8. That would be 9. And then again, 8 electrons to make it electrically neutral. You good? Okay. So guys, with that done, let me show you the first page of the test that you're going to sit down to Wednesday. You ready? This should not come as a surprise. This is what the first page of the test is going to look like. It's going to be a big old table, and you're going to fill the thing out. Okay? So guys, this is as bad as it gets. I picked worst case scenarios for you to show you just how wacky this can get today in the homework and on the test. So rather than have you write these down, I'd like to do these with you. I'd like to point out to you the mistakes that you're going to make on the test. So guys, what I would encourage you to do is this. As we're going over these, make notes to yourself. Hey, don't forget this. Be sure you do this, so that as you're studying for the test, probably Tuesday night, you can go back to that list of hey, don't forgets, so you don't forget. So guys, let's do this together. Magnesium is element number 12 over here on the periodic table. So the first thing we're going to do is name it magnesium. Does that need to be capitalized? Not necessarily. There are not capitalization rules for the names. Either way is fine. Okay. Now guys, magnesium is element number 12 with a mass, average mass of 24. So how many protons? 12. How many neutrons? 24 minus 12, also 12. Now, how many electrons should it have? 12. How do we give it a +2 charge? 10. Yep. So again, don't let it trick you. You're going to get in on the test and you're going to maybe sort of screw this up in your head. Plus means remove. Okay. You okay on that one? Stop me if you need. Okay, so we're done with magnesium. Let's do lead. So guys, lead is right down here. Lead is element number 82. Now guys, what is the mass of lead? 207. The average mass is 207. What does it mean that this says 209? Use that mass. So this mass is 209. It means we're looking at a mass other than the average. So what are we going to do? Guys, don't miss this. First of all, lead. It's abbreviated PB. That's for the Latin. But guys, notice that it's big P, little b. It's got to be big P, little b. So when you do your abbreviations, the first letter is capitalized. The second letter, if there is one, is lowercase. Then, guys, you got to do this. Write the mass into the abbreviation. So the rule is this. If you are looking at a mass that is not the average, it's got to go in the abbreviation as a superscript on the left. I'll give you a second to write that down because I know you're thinking to yourself, I'm going to forget that. Largely because you're going to forget that. You okay? Okay, so now guys, how many protons? 82. How many neutrons? 209 minus 82, 127. And then electrons, 82. Yeah? Guys, this one is ridiculous. This third one is a little crazy. Can we go into it? Okay, so guys, aluminum. So the first thing we've got to do is write this out. Al-um-in-um. Again, it doesn't matter if it's capitalized. Then we find aluminum, element number 13 on the periodic table. And guys, what is the average mass of aluminum on the periodic table? 27. But this is telling us it's got a mass of 25. That is not the average mass. So what do we have to do with this number? Put it here and also put it there. So guys, be careful. Again, if it's not the average mass, it goes here and it also goes there. Now, 13 protons. And now how many neutrons? 25 minus 13 is 12. And now, guys, we got another problem. How many electrons should aluminum have? 13. What does it mean that it's only got 10? It's got a +3 charge, which has to go right there. That's a lot to keep track of. But that's as bad as it gets. You guys okay? So I think if you're okay, we can probably not do this one. It's pretty much the same as the one we did before, a little simpler. You guys okay? All right. Guys, one last thing to do. We've done ions, we've done isotopes. Now it's time to talk about average atomic mass. All right, so you ready for the big idea and the extra credit? Guys, this is crazy. Average atomic mass. The idea goes like this. Inside this pencil is carbon, right? And this carbon exists as 3 different isotopes. Mass of 10, 12, and 14. Again, guys, what is that number on the periodic table then? The weighted average. But now, guys, how on stinking earth do they come up with that number? Well, you ready? Watch. Here's what they do. They take this piece of carbon and they break it into individual atoms. And they take those atoms and they weigh them and then they put them in piles. So they take this atom, oh, that weighs 12, we'll put it there. They take this, oh, that weighs 10, we'll put oh, that one's 12, oh, that one's 14. And they weigh them and put them in piles. Now guys, think about this. How small are atoms? Remember atoms in a grapefruit like blueberries in the earth? Guys, how on earth do they do that? How do you take atoms and weigh them and put them in piles? That's your extra credit challenge. Guys, how do they do this? How do they take atoms and weigh them and put them in piles? This is what you can do for extra credit. Guys, watch. Here's what you're going to do. Go to our website and go bump and go here and go here. So guys, this is today, and you'll notice, okay, I called it enrichment because extra credit makes me sick. But guys, here's what you're going to do. You are going to watch this video that explains to you how they sort and weigh and count atoms. It's called mass spectrometry. You skip over the ad. I love that we can skip over ads. And then you run into one of my favorite people on the whole wide planet, this guy from Bozeman Science. He's actually crazy bright. And he made a series of chemistry and physics videos. So guys, the answer to how do they weigh and sort atoms, that's the machine. It's called the mass spectrometer. And he will explain to you how this thing works. For some of you, that's going to be enough and you're going to understand it. If it's not enough, you're going to maybe need to do your own research. But guys, in either case, here's then what you're going to do. Down here where it says assignment, this is the extra credit assignment. It reads like this. It says, after watching the video and doing additional research, if you deem it necessary, if you do, please cite your sources. Type a well-developed double-spaced paper addressing the following thoughts. 1, how does a mass spectrometer work, or how does mass spectrometry work? To answer the question, first address the technical details of how it works. Then, in a separate paragraph, develop an analogy you might use to describe how this thing works to a younger sibling who knows very little about atomic structure. So first of all, have the technical talk, and then have the dumbed down talk using analogy to explain how it works. Then guys, second thing you'll address is how do we collect and analyze mass spec data? And then finally, what does this mass spec data allow us to do? This is due on Wednesday, the day of the test. Guys, understand that extra credit is not intended in this class to turn F's into A's. It is intended maybe to turn B pluses into A minuses though. So guys, this will count as about 1.5% of your grade. So if you've got that 89, now it's an A minus. If you've got a 69, it ain't going to become an A. But if you're interested in some extra credit to give you that little kick over a grade break, this is the way to do it, and it's due Wednesday. Good? All right. So guys, whether you choose to do that or not, you still have to know this. You've got to understand what we do with this mass spec data. So you've got to be able to analyze it. You don't need to write this down, just trust me. This is all conversational. So guys, the idea is this. Mass spec allows us to figure out the average masses of all these different isotopes. Now, guys, in order to do that, we understand that that's why the numbers on the periodic table aren't whole numbers. They're averages of isotopes. But to figure this out, we need to know two things. We need to know the mass of each of the isotopes, and we've got to know how much of each isotope exists, because it's not a third, a third, a third. So what is it? Well, guys, in the example of neon has a mass of 20, 21, or 22. But again, it's not a third, a third, a third. It's actually about 90% this, it's about 1/4% this, and it's about 9.25% this. So guys, this is way skewed towards the isotope that has a mass of 20. So, given these numbers, what is the average mass of neon? Well, it's on the periodic table. But how do we come up with that number? This you need to write down. Guys, this is how we come up with the number. This is an equation you need to be able to know and manipulate. So AAM is average atomic mass. And AAM, average atomic mass, equals squiggly sexy E times mass times percentage divided by 100. Do you guys know about squiggly sexy E? You do? Oh, good. Yeah, so it's sigma. Good. Well, we'll talk about it in a second for those that don't. So guys, average atomic mass is equal to, it sounds like some of you know that's actually not sexy, that's sigma, times the quantity, mass times percentage, divided by 100. So guys, first of all, let's unpack sigma. So guys, this is the Greek letter sigma, which eventually became the English, well, the Arabic, because we're on the Arabic alphabet, the Arabic letter S. And S is the first letter of the word sum, S-U-M, which in math means what? What do we do if we sum something? We add it up. So guys, sigma means sum, which means to add up. So the bottom line is this. This says, take the masses, multiply them by the percentages, add them all up and divide by 100, and that gives you the average atomic mass. So guys, what are the masses? Well, in this case, they're 20, 21, and 22. What are the percentages? Well, in this case, they're 90.27 and 9.3. So we're going to do the math. And guys, it looks like this. You ready? Average atomic mass is equal to 20 atomic mass units. And guys, watch units. These masses are in AMUs. 20 atomic mass units times 90.5%. There is our first mass times percentage. What are we going to do now? The next one, and we're going to add them together. So now we've got 21 AMUs times 0.270%, and then to that we are going to add 22 AMUs times 9.30%, and we're going to divide that by 100. Now guys, assuming that you've become one with your calculator, when you do all the math, it works out to 20.2 AMUs. That's the number on the periodic table to the accuracy of the problem. But guys, what I'd like to do is give you a second to at least interface with your calculator. Make sure that you can coax your calculator into coming up with 20.2. If you can't, I would love to work with you individually. And then guys, you've already got your homework. On the front, and I'll tell you again, guys, the front of your homework is the first page of the test on Wednesday. Different examples, but same idea. So on the front of your homework is a table like we did in practice. On the back are 2 average atomic mass problems. We will grade this on Monday. We will do a lab on Monday. We'll take a test on Wednesday. Guys, feel free to start on your homework. The answers are on the wall. If you need help with your calculator, I would love to help. That is all.